Let's start with a simple problem. Large language models are incredibly powerful, but they don't know your data. They don't know your company policies. They don't know your internal documentation. And they certainly don't know your latest reports or customer interactions. So, what happens when you want to use AI inside your organization? You need a way to connect the model to your data. That's where something called Retrieval-Augmented Generation, or RAG, comes in. Today, we're going to break down one of the most important and most commonly used patterns, lazy RAG. Welcome back. Thanks for watching. Continue to comment, continue to like, and all that great stuff. Really appreciate your support, and subscribe. All right, at a high level, RAG solves a very specific problem. Instead of relying on only one model or what it was trained on, we give it access to external information at the time of the question. So when a user asks something, the system will find relevant documents, add them to the prompt, and then let the model generate a response using that context. This changed everything. Instead of guessing, the model is now grounded in real data. And that means fewer hallucinations, more accurate answers, and responses that are actually useful in business settings. Now, there are different ways to implement RAG. Some are complex, some involve multiple steps, reasoning layers, or even agents. But the simplest version is lazy RAG. Lazy RAG is exactly what it sounds like. It waits until the user asks a question, and only then does it go and retrieve information. There's no planning ahead, there's no multi-step processing, no pre-processing at query time beyond a simple search. It's a very direct flow. The user asks a question, the system retrieves relevant data, the model generates an answer. That's it. Everything happens in real time, on demand. And that simplicity is exactly why lazy RAG is so widely used today. Let's walk through how this actually works behind the scenes. First, we prepare the data, of course, right? Before anything else, your documents need to be processed. This includes things like collecting your data and breaking it into smaller chunks. We convert those chunks into embeddings, and then we store them in a vector database. Chunking is a super important capability because you don't want to search the entire documents. You want to search meaningful sections of documents. So instead of having to look at a 50-page document, you might have hundreds of smaller chunks. Each chunk is then converted into an embedding, which is essentially a mathematical representation of its meaning. Next, the user asks a question, and the process begins. Let's say the user asks, "What is our remote work policy?" That question is also converted into an embedding. So now we have a vector representing the meaning of the question. We take the vector search next, where the system goes into the vector database. It looks for chunks that are semantically similar to the question. Not exact matches here, but meaning-based matches. So it might return sections about things like remote work guidelines or hybrid schedules, maybe approval processes. Typically, the system retrieves the top few matches, maybe 3 to 5, but it can be more. Next, we build the prompt, right? We take those retrieved chunks and insert them into the prompt. So the model will see something like, here is the context, here is the question. Answer only using this information. This is the key moment here. We're giving the model the exact information it needs to answer correctly. Finally, the model generates the answer, but now it's not guessing, we hope. It's using the retrieved context to produce a grounded response. So if we don't have that type of documentation, we might get hallucinations, just something to keep in mind. So why the name lazy rag? And the reason is because the system does no extra work up front. It doesn't try to interpret the question deeply. It doesn't break it into multiple parts. It doesn't run multiple searches. It simply waits, retrieves, and responds. Compared to more advanced architectures, it's intentionally minimal. Now, there are a few reasons lazy rag is so popular. First, it's really simple, right? If that's not clear at this point. Next, you don't need a complex system to get started. It's fast to build with modern tools, and you can have a working prototype in a day or two. Finally, it works really well for many common use cases. Things like internal knowledge bases, documentation search, customer support, system policies, all of those things. If you need to retrieve information and summarize information, lazy rag is often more than enough to complete these tasks. Now, it's not perfect, of course. One limitation is that it depends heavily on the quality of the search. If the wrong documents are retrieved or we don't have proper documentation, the answer is probably going to be wrong. Another issue is that it doesn't handle complex queries very well. If a question requires multiple steps of reasoning, lazy rag may struggle. And finally, there are limits on how much context you can include. All large language models have a context window, and they can only process so much text at once. So you have to be really selective about what you're retrieving. Lazy rag is one of the simplest and most practical ways to connect AI models to real-world data. It retrieves information at the moment a question is asked, and it uses that information to generate better answers. It's not the most advanced architecture, but it's often a great starting point for building real AI systems. And in a lot of cases, it's actually plenty for what you need. Hopefully this video helps to clarify what lazy rag looks like and you found it interesting. If you did, let me know. If you think it could improve, also let me know. I appreciate the feedback. Next, we're going to talk about agentic AI and all of this exciting stuff that's happening with agents and all of the great productivity and simplicity we're driving with this new technology, all generated from LLMs. That's all for now. Have a great day. Bye.